Hi, I'm back again, and in this module I want to talk about the basic architecture of a computer so that as we use the computer to create documents, we have some idea of what's going on under the hood. So I'm going to access the Word document that we were looking at in the last module. I'm going to access it from the file system. And a couple of ways I could do that would be to go to the Start menu, choose Computer, open Folders, and find it. Another way of doing it would be to launch the application that was used to create the document, in this case Microsoft Word, and go to the File menu, and then I would have two choices. I could either choose Open, which would provide me a window into the file system where I could navigate and find the file, or if it's a file that I've used recently, and it is, then I may be able to find it from a short list, and that's a real time saver because I don't have to navigate through the file system structure. So I'm going to go ahead and open this file, and there's the first diagram that we looked at, and now I'm going to take a look at another diagram, and unfortunately I changed some things, so I'm going to have to make an adjustment here. Bear with me, please. And alright, so the diagram that I want to look at right now is the one that I have highlighted, okay, and this is known as the von Neumann computer architecture. It's named after a American mathematician who was famous especially back in the 1940s because he had a major role in the Manhattan Project, and then after that concluded, he was given an assignment to evaluate the first computer that was built during World War II, a computer called the ENIAC. And von Neumann, working for the government, for the Defense Department, looked at the work that had been done on computers up to that point and then made recommendations on how computers should be built in the future. And even to this day, computers are still built on this basic architecture. And so let me walk you through this. This is what electrical engineers call a block diagram. So it's a very high-level view of the electronic architecture of a computer. And what you find in this diagram is that everything seems to be connected either directly or indirectly to this center part of the diagram labeled CPU, or Central Processing Unit. And the Central Processing Unit turns out to be the brains of the computer. It's where the circuits that perform arithmetic and logic operations are stored, and it's where the circuits that are able to decode and interpret program instructions are stored. So this is really kind of fascinating. As human beings, we're able to write program instructions, we're able to look at real-world problems, think through the steps necessary to solve the problems, develop a solution in a computer programming language, then have that computer programming language transformed into a binary format so that ultimately our thoughts, our instructions on how to solve a problem can be delivered to the circuits of the control unit as a sequence of high and low voltage states. So where a 0 would occur in binary code, there would be a low voltage state. Where a 1 would occur in binary code, there would be a high voltage state. And it's fascinating to me, even after being in the field for over 30 years, to think that a human being can see the solution to a problem, express it in a programming language, and ultimately provide it to a piece of machinery to perform the task and the machinery at that point is really following the instructions that were created in the human being's mind. Okay, so all that happens with the CPU. If you look at most computers today, at least the computers that are used for home, notebooks, desktop computers, that kind of thing, most of them have an Intel processor. So the Intel processor is the CPU. When you see that in the advertising, that's what they're talking about, the brains of the computer. Another thing that you see in advertising, and this was one of von Neumann's contribution, is the amount of memory that a computer has. So if I go to Best Buy and look at computers tonight, I wouldn't have to look very far. In fact, there's probably a sticker or some kind of document with the computer as it sits on the shelf that tells me what kind of CPU it has, and it also tells me how much RAM, or primary memory as von Neumann described it, how much internal memory the computer has, and then there would also be undoubtedly some information about how large the disk drive is, or how large what von Neumann would call the secondary memory is. And so let's take a look at what primary memory and secondary memory do. Secondary memory is long-term memory, so any program that is installed on your computer is installed typically on a hard drive, although that technology is changing. And then as the instructions need to be processed, they're transferred, a copy of them is transferred from secondary memory, typically a disk, into the circuits that make up primary memory, and then from primary memory the instructions are fetched, and that's the term that's used, are fetched by the CPU, where the control unit interprets the instruction and then tells the rest of the computer hardware how to carry out that instruction. So long-term storage is where all your programs reside, and then as they're needed to be executed, copy of it is put into primary memory, and then the instructions are fetched one by one. And the other thing that von Neumann suggested, and it seems so obvious, here in the year 2013, but you have to understand that von Neumann proposed this in the late 1940s, right at the end of World War II. And what he proposed was that all computers that were built thereafter, after the first computer, should have some kind of input device and some kind of output device. So he wasn't specific in terms of the technology that would be used. He just, made this architecture, designed it in a very general way, and over time, technology has changed. So there was a time when key punch cards, paper cards, were used to store instructions and data that needed to be input into the computer. And there was a time when the output of a computer was directed to a printer. And nowadays, the input might well be a scanner, a microphone, output might be stereo speakers, or any variety of things. So the basic architecture remains the same. The technology continues to change, but every computer, whether it's a computer with a Windows operating system, or a Macintosh operating system, or even an Android or iOS operating system, they all are built on this basic architecture. And this architecture has been around for well over 50 years. Okay, so now let's move on to something else. Let's look at a higher level. If I want to create a document and I want to manipulate the text or any objects that I create, graphics, audio, video, components. How do I do that? Well, you will hear me as I progress into the topic of document preparation talk about the Windows clipboard. Okay, so as I use a Windows-based computer with a Windows operating system to create documents that represent real-world things. You'll hear me talk about the Windows clipboard. So what is the Windows clipboard? The Windows clipboard is a reserved area of memory where data, be it text, be it numbers, be it graphical objects, whatever it might be, it's a place in memory where data can be stored while it's currently being processed. So how do I interact with the Windows clipboard? Well, I can interact with it two ways, and the lines with the arrow points depict this graphically. Two ways that I can interact with the Windows clipboard with this area of memory is I can take some source data, could be text from a word processor, could be a picture, could be a file even. I take some sort of source data and I can move it to that area of reserved memory that Windows calls the clipboard two different ways. I can make a copy of it, and when I say make a copy of it, think about going to a copying machine. You have a source document, you put it on the tray, the panel, whatever you call it, and you push a button and it produces a second instance of it. The original is preserved and there is a second instance of it. So if I take some source data and make a second instance of it, I'm performing a copy operation. And the Windows shortcut keys to do this is to execute a Control-C. Hold down on the Control key in combination with the letter C. C is in copy. Another approach that I can take with my source data, be it text, numbers, some other more elaborate structure, an object, I can cut it. And if I cut it, what I do is transfer it. I remove it from its original location and put it on the clipboard. And so the original element is going to be transferred, eliminated from its source location, put onto the clipboard. Once on the clipboard, I can move it to some new destination. I can move it to that new destination, new folder, new area of a document window, depending upon what it is I'm transferring, whether I'm transferring a file or whether I'm transferring contents of another document. I can transfer from the Windows clipboard, in other words, write it to my destination location using two keys in combination called the Control key and the V key, Control V, and when I execute that kind of transfer, I am pasting. I'm removing from the clipboard onto the destination location. So if I want to copy something, Control C, and that will preserve the original object, but make a duplicate and put it into memory. If I do a cut, Control X, it will transfer, eliminate it from its original source location and put it on the clipboard. Once on the clipboard, I put it into the new destination location using the Control V keys in combination. And there you have the basic operations that are necessary to copy and paste from one source to another using the Windows clipboard.